What's up, Daniel? Daniel, everyone just looked at me like I'm a freak. Hopefully, baseball in Arizona is going well. Go see a spring training game and live it up. I live for baseball. Okay, Daniel, you just missed 20 minutes of share and care time as we talked about spring break, so hopefully your life is good down there. Here's the plan for the week, everyone. The next 2 weeks, you have a test next Friday. It is not your partner test, so you don't have a partner anymore, okay? But next Friday is the test. This is the rest of Chapter 9. Notice a lot of it is actually the front part of Chapter 9, the 9.3, 9.4, 9.5 stuff. Today, 9.3, tomorrow, 9.4. 9.5 is a 2-day thing. Wednesday is TCAP, so you only have 70 minutes with me, so it's a little bit shorter. And so then I finish everything on Friday. And then Monday, again, I'm gone for the wedding. And then Tuesday, we have 9.8. Then 2 days of review, test on that Friday. Most likely, if you want, I could probably pencil in something like this is an after-school review session as well. Okay, AS, after school. On the homework assignments for each day, there are going to be 2 parts to it. There's going to be the book homework that's on that section. And then there's going to be, in the book as well, a review set assignment. And they do a really good job in the book where they go, okay, here's the problems for 9.3. And then the review set that I attach to it are all review problems from 9.1 to 9.3. And then tomorrow when you do 9.4, it's going to be, there's a 9.4 homework. And then the review set will be 9.1 through 9.4. And it just kind of slowly goes, here's something new that we learned. Now here's everything together. Here's something new that you learned. Here's everything together. I never grade homework, so you don't have to do them. But the review sets are really good. Because the test, what's going to happen is on this test next Friday, the whole thing's going to basically say this. Does this series converge or diverge? That's it. That's basically what most of the test is next Friday. I don't tell you how to do it. I just say, does it converge or diverge? So you're going to have this toolbox of lots of tests that you can use to determine if a series converges or diverges, okay? And so what this whole 2 weeks is about is learning lots of different tools to check if a series converges or if a series diverges. You knew one of those tools already. What is it? Divergence tests, okay? So you already know the divergence test, and that says what? Cool. So if the sequence goes to a non-zero thing, if it goes to 4, the series diverges. If the sequence goes to 0, we don't know. It could converge, it could diverge, okay? That's the only thing that divergence test shows you. It tells you if it diverges. It doesn't tell you if it converges, okay? The other 2 that we've known are the geometric series and the telescoping series. Those, you know they converge, and you know exactly what the sum converges to, okay? So what I want you guys to do, and it'll take about 30 minutes, okay, is this. You're actually going to take the partner quiz again, not for a grade, but the very first partner quiz over 9.1 and 9.2. You guys remember how we had 2 partner quizzes, okay? This one, 9.1, 9.2, was basically about geometric telescope and the divergence test. And it's just for you to refresh what we're about to do, because 9.3 should flow right from 9.1, 9.2. Okay? So for the next 30 minutes or so, I want you guys to pull up on Blackboard the partner quiz. I already posted on Blackboard today the link that you need to submit. And then submit for me, just to see if you kind of have a reminder of what we're learning. And for you, Daniel, do the same thing, because it will be good practice for you. Daniel, you can hit pause, go do it. When you're done, hit resume, and we'll keep learning from there. That's good? Okay, I'm going to try and email you your answers. I will for sure put them in this the notes for today. I don't know if I can email them to you because I've already done it once, like 2, 3, 4 weeks ago, but I think if I reset it, I can send it to you. And then we'll look at some of the data if it's really bad tomorrow. Okay. For chapter 9, okay, so the things that we have learned and what our goal is. This whole test that you're going to have on Friday, next Friday, is a test on tests, like the divergence test. There's many more. Today you're going to learn the integral test, okay? The whole goal is, when do number series converge or diverge? That's all I care about for the next 2 weeks. Notice how I said, when do number series, okay? These series are all about numbers, okay? It's not about x's and functions like you spent a lot of time on the Taylor constructions and the power functions to represent an actual function. Now it's all about numbers. As you notice on all of the questions that you just answered, it was everything about numbers. There was no x's involved at all. It was just number plus number plus number plus number. So for a while, you might like that part of it because it's not about any functions. It's just about numbers right now. Okay. The test for divergence is the one that you always want to use first. And here is my little representation of it. If the red sequence, notice the dots, that's the sequence part. If the red sequence dot, goes to something other than 0, then for sure your series of adding them all up blows up. Okay? Because you can kind of think about that. If you try and add up all of these dots over here, as they all seem to approach the limit L, if I try and add up those dots, and think about adding up like little strips. This plus this number plus this number plus this number plus this and this and this and this and this and this and this. Do you agree those black strips, if I add up those black strips forever, it's going to blow up? Or if like I attach a black strip on top of a black strip and see how long that rope is, it's going to go forever. Now over here, when I add up these red dots, which is just adding up the length straight down, do you agree that black strip has a chance? If you connect all of those black strips together, the chance of it being a finite length, there is a chance. And same over here, when I connect these red dots straight down and I attach the black pieces together to make one long rope, it has a chance of being finite as well because you're pinching it at the end. What's up, Finn?
So what was the little formula that told the proper ones how to, like, something over n minus something?
I'll talk about that today. That's actually one of the tests. Okay? So, when you're adding up, realize when you're adding up, you're really adding up the length of the red dot down to the ground. So you're really adding up the black rope. Okay? Are you really adding up the green? No. But are you adding up the black? Yes. Is the green kind of the same story? It's like lots of blacks together. Okay? So if the black blows up, if the black length is forever long, that's divergent, and that's what the whole test for divergence says. Over here on these two, they have a chance of converging. You just don't know if they converge or not until I teach you more tricks of the trade. Okay? This one, the 1 over x, we learned that one day way back that one blows up, and this one actually works. So this one got pinched quick enough, and I'll teach you that a little bit today. Okay? For a geometric series, what you should remember is as long as r is less than 1, you are going to converge, okay? And that sum is a over 1 minus r. And the form it takes is a plus ar squared plus ar cubed, that sort of thing. And again, since everything for the next 2 weeks is about numbers, you might have something like 16 plus 8 plus 4 plus 2 plus 1. What is that? Geometric. Who's A? Who's R? So could I write it as like 16 plus 16 times a half plus 16 times a half squared plus 16 times a half cubed. And because of that, you could say the sum is 16 over 1 minus a half, which equals 32. Notice there's no x's in this. We did a lot of x work earlier before spring break. Okay? Until next Wednesday. So for a week and a half, no x's in the series part. And telescoping, okay? You normally have to break it into partial fraction decomp. You write it out, and you try and see what cancels. So in this case, I taught you, if it was n and n plus 1, how many guys are you going to be keeping probably? 1. N and n plus 2, the gap there is 2 on the bottom, so you're probably going to keep 2 guys. Okay? And then the whole thing is you kind of lay things out, and some colors match where they cancel, and some colors don't match up, and you get to keep those. Okay? And hopefully the little review for 30 minutes helped you on that. So those are the 3 things we've learned. And the rest of the next week is this. All I care about is, does the series converge or diverge? Notice, if it diverges, you're done. You just throw it away and say it's useless to me. It blows up. I don't want it. If it converges, all you're going to need to tell me is it converges. You are not going to have to tell me what it converges to. The only ones you'll ever tell me what does it converge to are the ones I've already taught you, geometric and telescope. So the question I'm going to ask you over and over and over again is, does the series converge or diverge? If it diverges, done. Don't want it, throw them away. If it converges, cool. Hey, it works. Am I going to ask you what it converges to? No, I'm just going to say, hey, it converges. You guys okay with that? That means the sum would add up to a finite number, and that's all I care about. Okay? Okay, so time to learn some new tests. Here's the first one, okay? It's the integral test, okay? If f is positive, continuous, and decreasing for x greater than or equal to 1, and you have a sequence that's basically can be represented by a function, then the series and the integral either both converge or they both diverge. Okay, so I'll give you a second to write that, and I'll just hit pause so I don't waste video. So the whole idea is, if an integral converges, then the series will converge. Okay. I already kind of showed you this on the last page. Okay. This stems directly from the divergence test, that if the integral blows up, which means it leaks out forever, and it doesn't go to a 0, then the integral would be infinite, so would the series. Okay. Basically, the key is going to be this. If you can integrate the function, do it. As long as those 3 conditions are met. So every time you do these problems, I'm going to want you to say, you're going to show me those 3 things. And what were those 3 things up top again? What do I need to have? Positive, continuous, and decreasing. Okay? So as long as your red dots are above the ground, they're bending towards the ground, and they're always continuous, we're going to be good. So a lot of that's the calc book, what it says, and then I'm going to show you a picture of kind of the representation. Okay? So for this picture, think of this. Okay. Let's say n equals 1 to infinity of an. So think of them as like, here's a1, here's a2, here's a3, here's a4. Are those positive dots? Are they positive values? Especially if I put them out like, okay. So they are positive. They are what going to 0. What was it? My 3 things? Decreasing. Okay. Now I'll talk about the continuous part. Okay. Let's say that thing, let's say the ANs are all represented by like 1 over x squared or something like that. Okay? So I'll write it as AN is 1 over n squared. So I'm really trying to add up 1 over n squared. Is 1 over n squared as a function. So as a function, that's 1 over x squared. Is that continuous? Okay, so that's continuous. So imagine it being like that. Okay. So this part here, if I wanted to find those sums, on the last page, I told you that's the same as doing black lengths added together. You guys agree? If this is 1, this is 2, this is 3, this is 4, that would mean that these lengths here are at 1. I got 1 over 1 squared, which is 1. At 2, that's 1 over 4. At 3, it's 1 over 9. At 4, it's 1 over 16. It would be doing 1 plus a 4th plus a 9th plus a 16th. Do you guys agree with that? That is the sum of 1 over n squared from n equals 1 to infinity. Think this is the total black length. You guys are okay with that? If I took each black length and connected them, does that add up to a finite number? Now, that would be the same as looking at a left Riemann sum. Look at this. If I attach this and I go what are all of the widths of those rectangles? 1. So all of these rectangles, all rectangles of width 1. So the sum would still be 1 times 1 plus 1 times a 4th plus 1 times a 9th plus 1 times a 16th. And it's still the total black length. Do you guys agree? Since the widths are all 1, it's either you can think about adding up the length of the rope, or you can think about adding up each little rectangle. Okay? Now the whole integral test says this. If the integral, the real integral of the whole thing, if that blue integral blows up, what do you think all the skyscrapers would do added together? Blow up. But if the blue integral converges, do you see all the black stuff is like below it? So if the blue is the cap to the black stuff, and the blue works, it converges, what should everything underneath it do? Converge. Do you kind of see the idea of it? It's basically saying, instead of looking at little ropes, instead of looking at black rectangles, basically if you kind of cap it with the integral, meaning the whole blue stuff, if the whole blue stuff is good, then the sum of the series is good. It's the same picture I drew here with adding up all of the black lengths. Could I have thought of those black lengths as rectangles? Because all of those widths would be 1. Those black rectangles added up will have the same idea as the green integral. So if the integral converges, the black rectangles converge. If the integral blows up, the rectangles blow up. Okay? A little bit better on the idea? So I will show, I'll just make sure. The blue area is the integral. The black boxes converge or diverge based off the blue area capping. What's up, Finn? Question? Oh, drink. Okay. Okay, so let's look at a couple. First one, n equals 1 to infinity of 1 over n squared plus 1, and then we're going to do the same one with an n on top of it, okay? And we're going to kind of look at these. So I'm going to stop this one, start a new video, and then we're going to take a look at them, okay?